All right, students, so we are starting to get a little bit farther into 5.1, and we are going to talk about substitution now. And the first system that we have here is really already set up well for elimination, but we're going to do substitution with this one because we want to cover substitution first. So the principles behind substitution is that we are going to solve one of the equations for one variable, and it's our choice. We can solve for x or y. So I'm going to take this second equation right here, and I want to leave the x on the left side by itself, but I'm going to add a 2y to both sides so that I get the x by itself. Okay, so we have this. So the x plus nothing gives me the x. The negative 2y and the positive 2y will cancel, and that's equal to 2y minus 7. All right, so now I have solved the second equation for x. Now, I'm going to just cross this one out, showing that I've already consolidated that into another equation. And now I'm going to use substitution, which means I'm going to use this one up here as my framework. And I'm going to substitute in where I see an x here. I'm going to substitute this x in. So I'm going to rewrite my framework here. I'm going to leave a big place for that x. 3x minus y equals 4. Okay, so I'm just rewriting my framework with a big spot for the x. Then I'm going to take the x out and substitute in 2y minus 7. All right, so now, remember, whenever I have these parentheses, it's kind of like those terms are in jail. Okay, I cannot do anything with them until I break them free by using a distribution process here. So this 3 over here has to be distributed to both parts. So 3 times 2y is 6y, and 3 times a negative 7 is a negative 21, minus the y that's already sitting here equals 4. Okay, so now, after I've broken them out of jail, I'm able to add the 6y and the negative y together to get a 5y. And if I add a 21 to both sides of the equation, so I'm going to make a little bitty plus 21 and a little bitty plus 21 over there, then this is going to go out, and I'm going to end up with 5y equals 25. Well, if I divide both sides by 5, I get that y is equal to 5. Okay, and that is half of my solution. All right, so now I'm going to go up here with my y is 5, and I'm going to plug y is 5 right here into this second equation that I had. So I'll put a y is 5 right there, and I get 10. 2 times 5 is 10. Take away 7 is 3. So I have y is 5 and x is 3 as my solution. And I just used this equation, which was my second equation rearranged, to plug in my y is 5 to get my x is 3. So I will use this equation, which I haven't touched for a little bit, and I will plug them in just to check. So I'm going to plug the x, which is 3, right here in the spot where the x is, and I'll plug the y is 5 right here in that spot right there. So I have 3 times 3 is 9, take away a 5 is a 4. So that verifies that the point 3, 5 is my solution, and that is using substitution. Here's another problem that we can do very easily with substitution, because remember, to solve with substitution, we always want to get one of our variables by itself. Okay, well, we already have x with no other x's there. All right, we also have y already solved for itself because there's no other y's in there. So why don't we just use this x that's already solved by itself And let's use this for our framework equation. Okay, so we'll just copy y is 3, and I'm going to make my little x right there, stretch it out with a parenthesis. Y is 3x minus 1, which is our equation. But now instead of the x, I'm going to take out the x. I'm going to substitute in a 2y right here in place of the x. So now I have an equation, one equation in only one variable, and the variable is y. So when we distribute this through here, we've got y is 3 times 2y is 6y, take away 1. And I don't want y's on both sides of the equation, all right? So if I subtract a 6y and subtract a 6y from both sides of the equation, I get y, take away 6y is negative 5y. 6y minus 6y cancels, and I'm left with this little negative 1 over here. So y, to get y by itself, I need to divide by negative 5 on both sides of the equation. The negative 5's cancel here, and I get y equals negative 1 divided by negative 5 is 1/5. 1/5. So y is 1/5. We're halfway done. Okay, so we'll put it up here. Y is 1/5 because we need to come up with an x. All right, so I'm going to plug. See, this one has x solved all by itself. So I'm going to plug the y that I know in here for the x. For the y to get the x. So I'm going to have 2 times, and then this is going to become a 1/5 right here. That's going to substitute in for the y. 2 times 1/5 is 2/5. So x is 2/5. Okay, so now I have my solution, and it is the point 2/5, comma 1/5 for my x and my y, but I should check it. Okay, so I'm going to plug in my x right here. I just used this equation, so I'm going to go use the other one to check. And I'm going to have 3 times where the x is, I'm going to plug in the 2/5. Since I'm kind of out of space, I'm just going to take the x out and plug in a 2/5. And then I'm going to take the y out and plug in a 1/5. And I'm going to check it. Okay, so I have right here 3 times 2/5 is 6/5. So I have 6/5. Take away 1, but remember that 1 is 5/5, getting a common denominator. And 6/5 take away 5/5 is 1/5. And that's what it's supposed to equal. Therefore, our equation is solved and checked, and our solution is 2/5, 1/5. Remember, this is one of those that just has a 1-point solution, and when we graph it, the two would look something like that. They're going to cross in 1 point and only 1 point. So back with more substitution in a moment. Okay, we're going to work one more substitution before we move on to work on elimination. And then we're going to do some with both. Okay, so we've got 3/4 x minus 1/5 y is 1/10, and x plus y equals 9. So we have a system of equations, and we're trying to solve. And we can see pretty much that our slopes are not the same. Okay, remember, my slope is negative a over b when I'm in standard form. So the slope of this one is -1, and the slope of this one is not -1. All right, so I know I'm going to look up for one solution. Okay, so this one is really almost there for being set up for substitution. I can either solve for x or for y. Let's just take the x away. So let's subtract the x and subtract the x from the other side of the equation. So now I have y, because these cancel, is -x plus 9. So now I have this one in slope-intercept form solved for y. So I'm going to use this one as my format equation, my basic equation, and I'm going to have 3/4 x minus 1/5 y. Okay, so here's where I'm going to put my y right here, equals 1/10. So I'm going to take out my y, and I'm going to substitute my other equation's value of y, which is negative x plus 9. Now, this one has some nasty fractions all over, and normally when I'm dealing with fractions, I will clear those fractions right out of there, and I'm going to show you how to do that in the next one. For this one, we're going to leave the fractions in, okay? Because we're just trying to work with our substitution right now. All right, so I wind up with 3/4 x, and then a minus 1/5. Remember, these guys are in jail over here, so I've got to break them out. I have to distribute minus 1/5 all the way through. So minus 1/5 times a negative x is a positive 1/5 x. And a minus 1/5 times a 9 is a minus 9/5 equals 1/10. Okay, now remember, I'm trying to solve for x. Wow, this is a mess. Okay, we only have x's, but we have to get a common denominator. So I'm going to go ahead and show you right now that nice little trick. Whenever we have an equation like this that has fractions all over, and we would like it to look a little simpler, we can multiply everything through by a least common denominator. Now look at all my denominators. I have a 4 and a 5 for my x, and the least common denominator for the 4 and the 5 is a 20. And then I've got a 5 and a 10. The least common denominator for those is a 10, but the 20 would take care of both. So we're going to take this equation and we're going to multiply the entire equation through by 20. We're going to multiply by the least common denominator. So I'm going to get a board and come back to you here. Okay, so I've recopied our equation on a clean board, and we're going to take this entire equation and multiply it by 20 over 1. Because remember, 20, I'm going to try to squeeze it in here. 20 over 1 is the same thing as 20. Okay, so pretend you can see that. All right, so now we're going to multiply each and every term on both sides by 20 over 1. So if I multiply 20 over 1 times 3/4, 3/4 of 20 is 15x. Okay, if you can't remember how to do that, then you could just say 20 divided by 4 is 5. 5 times 3 is 15. Or you could go ahead and multiply it. 20 times 3 is 60. 60 divided by 4 is 15. All right, so let's move on to the next term. We have 20 times 1/5. Well, that's just 20 over 5, which is 4x. Minus, so now we're ready to do 9/5 times 20. And 20 divided by 5 is 4 times a negative 9 is a negative 36. That's a constant. There's no x on that one. Okay. And lastly, equals 20 times 1/10. Well, that's just 2, isn't it? Look, I have one equation with no fractions in it. Much easier to deal with. So now I'm going to add the 15x and the 4x because those are like terms. Remember, like terms have like variable parts. So 15x plus 4x is 19x. And then minus 36 is 2. But I want to get the x by itself, so I'm going to add a 36, and I'm going to add a 36, and I'm going to get a 19x is 38. Well, if I divide by 19 and divide by 19, x is 2. Because 19 times 2 is 38. So 38 divided by 19 is 2. So I have my x value. All right, so I can go back up and find my y value. To do that, I'm going to have to go back to my other board. Okay, So remember here that we just solved that x is 2. All right, so we could put x is 2 right here and say 2 plus what equals 9, and the answer would be 7. Okay, so y is 7. Or we could have gone right here where we're solved for y, and since it says negative x and x is 2, it would be negative 2 plus 9 is 7 again. So we have y is 7. So we have found that our x is 2, our y is 7, and we just used this second equation to find out what the y was. So we will use the equation we haven't touched in a little bit, this one up here, to substitute them both in and check. Okay, so we're going to plug a 2 in here for the x and a 7 in here for the y. Okay, and we've got 6/4 x, well 6/4 because the 2 is the x, 6/4 minus 7/5 equals 1/10. So let's get another board here and just check that out because that's not something I can do in my head. So 3/4 times 2 minus 1/5 times 7 equals 1/10. Okay, so that's what we're trying to figure out. Is it true or is it not? We've substituted our 2 in for our x and our 7 in for our y. So now we end up with 6/4 minus 7/5 is 1/10. Okay, so now 6/4 is 3/2 minus 7/5 is 1/10. Now, can I get a common denominator of 10? Or I could multiply everything by 10. They both work. Okay, so we're going to do it both ways just so that you can see it. To get a common denominator of 10, I'm going to have to multiply this fraction by 5/5, right? I'm going to multiply by 5/5. Remember, when I multiply by 1, nothing changes, and 5/5 is 1. So I get 15/10 minus, okay? Now, what am I going to need? What form of 1 am I going to need to multiply 7/5 by to get something tenths? Okay, we need a 2, don't we? So we're going to multiply by 2/2, which is going to give me a negative 14/10. And when I take 15/10, take away 14/10, I end up with 1/10, just like I'm supposed to. Okay, if we had wanted to multiply by a least common denominator, I could have done that way up here. I could have multiplied by a 20/1 because 20, 4 and 5 and 10 all go into 20. The 20 divided by 4 is 5. 5 times 6 is 30. Okay, the 20 divided by the 5 is 4, times a negative 27 is a negative 28, a negative 7, excuse me, is a negative 28. And if I multiplied this one by 20, I'd get a 2. Is 30 take away 28 equal to 2? And it is. All right, so that one was solved using substitution. So now we're done with the concept of substitution. Basically, these are the steps for substitution. You're going to solve one or the other of the equations for either variable. Either solve for x or solve for y. You're going to use the other equation of the two as your kind of basic format equation. You're going to write it down. You're going to substitute in the variable that you have solved for, and then you're going to find the variable, the other variable, and you will substitute that one back into one of the equations to find the other solution, either x or y, and then you will use the equation you haven't touched in a little bit to solve the other one. Okay, so I'm going to come back with some more instruction on just elimination. And then we're going to do some maybe both ways so that you can see that they are two equivalent methods that will always give you the same answer. So this is Mrs. A, and may God bless your day. The end of 5-1-B.